Okay, let's get started. Any questions? I'm still getting students from India asking about if they go back over holidays, can they come back, get in this country? And I still don't know the answer. Okay, I hope to get your next assignment out soon. Let's share my screen. Oh. Keep on trying to find the magic which will stop my windows from being completely rearranged. Okay, so I want to start today talking about the builder pattern. And so the builder pattern is another creational pattern. If we want to create objects, if we want to create complicated things, and we want to, as I say, separate the construction from its representation, whatever that means. But the goal is we can use the same process to construct different objects from the same representation. How's that for terminology? It may not make any sense. So there's 3 roles in this pattern. The client or an object wants to build something. And there's a director and a concrete builder. And so the client interacts with the director and he keeps on asking, build me this thing. In this case, maybe we're building some sort of diagram. So we're going to, build a, create a diagram, add a line, add a rectangle here. And the director doesn't actually build anything. It has a concrete builder that it tells to do the actual building. And the reason we separate the director from the builder is, let's say we want to build some sort of diagram, right? But we may want to build that diagram in different formats. We may want to build it in a PDF, or we may want to build it on the web. I'll produce an HTML file, or maybe you want to do it in some format for Word. And so the idea is that we'll create different concrete builders, one to build the document in a PDF, one for the web. Then we can use the same client and the same director, but just give the director a PDF builder, and when we're done, we'll get a PDF out. Or we can give it a HTML builder, and when we're done, it'll generate a HTML diagram when we're done. Does that overview make sense? Doesn't look like it. So we'll go on and then try to come back to it, see if it makes sense a little later. So, the example, the RTF, or rich text format, designed to be able to convert a document from one format to another. So you convert to RTF, and then you can, other applications, you can read that in and generate a document in its format. So you may want to convert it to TeX, HTML, PDF, right? So, sort of a pseudo solution. We have a builder, RTF reader is going to be in some sense, be the director and the client. It's going to read the RTF file, and when it comes across a character, and tell the builder, add a character, change font, change paragraph. And each time we'll tell the builder what to do. Right, and so if we pass in a tech builder, when we're done, we'll have a tech document. If we pass in a PDF builder, when we're done, we'll get a PDF document built with the same instruction set, so to speak. All right, and we need this text converter class builder. And so we need, methods for characters, fonts, paragraphs. And then we create the subclasses. So we're going to ASCII converter, HTML converter. And then, right, I create my concrete builder. Right, here's my reader. I pass in the text I want to deal with, or the builder, and then the RTF text. We basically call build on the reader. And when we're done, and this is a key point, I don't ask my reader for the document, I ask the converter.
The converter is the builder, right?
The converter is a builder, correct. Now, why would we ask the builder for, in this case, the document or string rather than the reader?
The reader, or sorry, yeah, the reader could build multiple things at the same time, maybe?
Not multiple things at the same time, but if we give it different builders, it can build different types of things, right? And so the director has no idea exactly the type that's going to be built, right? Whereas the concrete builder does know exactly what type it is going to build. Yes, the builder creates the object, right? So the hard part about this pattern, once you understand um, how the director and the builder work together, is that we have to come up with this interface for the builder, right? So we need to be able to pass in um, different concrete builders, and the director has to be able to interact with them without knowing what type it is. So all the builders have to implement the same interface. So an example where you see the builder pattern being used, although XML is not as popular as it used to be at one point. Um, so here is a sample XML document, bunch of tags, and there are different types of tags, right? So the root element and first element, and then there's parameters to tags, and there's subtags to tags, and then there's content between tag, between the start and end tag. So there's a bunch of stuff, right? There's a fair amount of syntax here. So at one point, everyone went nuts with XML, and so I needed some way easy to parse it. It was being used for all kinds of stuff. And so someone came up with what they call SAX. I forget what the A stands for, simple something XML. And so in this example, the director is what they call the XML reader, and the builder interface is called the content handler. So the content handler interface has to define a method for each different type of thing that happens in XML. I mean, there's characters, end documents, end elements, start elements. So it contains, one method for every syntactic thing that can occur in XML. It's simple API XML. And so the whole idea behind this is we're going to make someone will implement the director for us. And then what we'll do is we'll implement our own builder to build whatever we want from the files we have. Right? So maybe you've got some configuration file for a particular application, and so your application has to be able to parse those files rather than doing it by hand, to worry about all components that can be in XML. We just create your concrete builder. And so here we're getting the director, implement a builder that implements the content handler interface. Pass in the builder to the director. Get our input file. Right. Give the director the input that we need, the XML file, and then it's going to parse it. It's going to then, as it parses that file, it's going to then direct the builder to, here's a character, here's a start tag, here's an end tag. And then when we're done, we ask the handler to get the result back. Give me the thing you just created. So far, so good.
Is that the handler is the builder in this case too, right?
Right. Yeah, the handler is what Sachs calls the builder. Another example of using a builder pattern in VisualWorks Smalltalk to build an interface, right? They had a file format which specifies the interface, right? When Android development or iOS development, they did the same thing. You'd have a GUI builder and you drag and drop things in there. And that GUI builder then generates an iOS and Android, a XML file. In this case, they had their own file format to specify the interface. And now when you want to run the application, we need to read that specification for the interface, parse it, and then in this case, generate the objects that represent that interface, right? So we need to specify that we have, buttons and panels, text fields, lists. And so then you'd implement one director to do this, and then you'd build the various builder to build different types of objects. So VisualWorks Smalltalk does this. Both Google and Apple did the same thing in their app development process with their GUI builder. Now, one side story here. Once you've got the director and the specification for the interface, they did this, right, assuming you're going to build a desktop application. But when the web came out, they said, oh, wait a minute. We could use the same specification, right, to build a web page. If you just build a different builder, and once you create that builder, I can now use the same director and the same instruction set to either build interface for an application or a web application. And so basically, with little engineering work, they're able to once they created the HTML builder, automatically have basically a switch to make this a desktop application or make it a web application, which was a very nice trick, very slick. Unfortunately, it didn't work very well. And the reason is when you're on the desktop application, when you click on a menu, you expect it to happen right away, right? And it does. Well, when you click on a button, you expect the response to be basically instantaneous. But when you take that same interface, right, and put it on the web, and all the logic has been handled on the server side, every action you do has that round trip delay. Send the request to the server does something and sends a response back. And that doesn't work very well on the web. And that's why JavaScript became so popular, because now you can do most of that interaction on the client side and then just do keep the business logic on the backside and handle the GUI interaction on the client side. So it's a great idea, but this shows you it's engineering and you have to consider all aspects. Any questions so far? People looking tired, worn out. If you've been staring at screens, wondering who's going to win the election, don't worry about it. You won't know for another day or two. Right? Okay, there's another, what I call a simplified builder pattern. You're going to see this far more often than the standard builder pattern. And they use the word builder. I almost feel embarrassed to put these together, but its primary use is when you're building an object that has lots of fields. You get tired of having a constructor with really, really long, like, here's an example of using the builder pattern. Say I've got a person object and have all these, a long list of fields that go into a person object, right? And, and they're all, most of them are strings, and it's a really bad idea to have like a parameter list of like 10 strings in a row, because eventually you're going to get some of those strings intermixed, right? You put the first name, the last name should go. It's a big problem. I once worked on a project where we're implementing something, converting a system from one language to another language. And at one point, the new system was getting different answers than the old system. And we spent days and days trying to figure it out. We got down to the point where one system was running, they're running different platforms. It was like, okay, let's compare the operating instruction set in each platform. Okay, add these two numbers, multiply these numbers over here, do them over here. We're getting the same result. Yes, yes. And eventually the answer was, oh, swap two parameters because they're both floats, one and not the other. And once we got all the arguments in the correct order, we were fine. So now the person builder sort of paradoxically has essentially the same set of fields. but it has a um, method for each field. And the key point is that each method returns the current object, right? So returning this. Right, so for each one of these fields, we're going to have a separate method, and each method inputs the value and sets the value in this object and then returns the object. Right, and so we keep on going, right? And then we've got one method we call create person on the person builder, and it then calls the humongously long constructor on the person object. And then the builder, you basically do this, right? Give me the new person builder, and then I can call set last name, set first name, right? Dot, set this, right? And then when we're done, call create person. And since each method returns the person builder object, right, we're still calling, so I call set last name on it, it returns the person object. So I'm still calling set person object on the same object, right? Is it clear what's going on here? Yeah, so all the calls are, test.set something, test.something, right? But we can chain them together because each method returns the object itself.
Is that like better than?
Well, it gets sort of annoying. You say test.set first name, semicolon, test.set last name, semicolon, test dot, right? Set, address, test dot, test dot, test dot. It's also a little bit easier to read this way once you understand what's going on. So it's basically a way of saving the programmer some typing and making things a little more readable. And we can also then have defaults, right? So we can have our builder, in this case, could have defaults for some of the values. And so then we don't have to call set this, set that on everything. Is method chaining, in this case, okay? Yeah, in general, people argue against method chaining like this, in part because we could have, in general, when you chain methods, you have no idea which object you're dealing with eventually. But in this case, we're always dealing with test here. We're always in the same object. Now, some languages have constructs built in to do this automatically. When you want to send the same method, multiple methods, the same object. Um, yeah. So you can improve it, but the basic idea is the same. Um, so in Android, they use this. Um, to build the notification object, use a builder. And so you basically get context like this. And you may, maybe you don't want to give icons, so then you don't have to, right? Um, so this is, it's definitely different than the builder pattern from the text. But as you can see in the Android case, they do use the term builder. It means something different, but you'll see this more often than you'll see the builder pattern from the text. Or at least I've seen this more often than I've seen the builder pattern from the Gang of Four textbook. Any questions? So how is the builder pattern, not the simplified one, but the one from the text, different or similar to the strategy?
One way I think they're different is the strategy kind of sets the behavior. Well, our example is like a collection object, but the builder is specifically for producing a new object.
Yeah, so the builder pattern is more specific, right? Where we could say that building an object is an algorithm, right? But really the intelligence is probably more in the director than in the actual builder object, right? Whereas in the strategy pattern, it's sort of reverse, right? The algorithm itself is in the strategy, where the overall algorithm is in the director, not the builder.
Hey, sorry, could you expand on why you would say that the intelligence is on the director? Is that
Well, if we go back to this example, what does the content handler or the builder do here? It said, here's a character, right? And then it's going to insert a character. But the director has to know, in this case, how to parse the instruction set and what instruction to pass on to the builder. So it's more like we're telling the builder, go get a 2x4, cut it in half, now put it over there, now hammer in some nails. So that's why the builder knows how to build something, but it handles it in smaller sets of instructions, right? Whereas the strategy is like, okay, for example, in the layout example in Java, we say, here's all the widgets in this interface. Go lay them out. Go, and so the complicated algorithm there where the builder's like, well, just add another paragraph, add another. So in the case of the builder, right, it just appears to me that the algorithm the builder implements or represents is just constructing smaller pieces. So it seems a little bit different than the strategy to me. Besides just built, just built an object, whereas a strategy could be do many different things. He isn't quite happy with that answer, but he's thinking, staring at his screen.
The example you gave for the builder, it reminds me a little bit of the visitor example where you needed a different approach to print trees in a different way.
Yeah.
So I guess I'm confusing between the two situations because I keep thinking that we've already covered this and the visitor would be the approach, but
yeah, that's a very good question. What's the difference between the visitor pattern and the builder pattern, right? In the visitor pattern, we already have some sort of structure of objects, right? Whereas in the builder pattern, in this XML example, we don't. We just have a string of text, right? So we can't build a visitor to go visit the text, but you have to parse the text and build a syntax tree, right, before we can actually apply the visitor. We're actually reading XML and, oh, here's a food tag, so now we're going to tell the builder, here's a food tag. If we had if we took the XML and built an XML tree, right, which happens, say, in the web when you have a HTML document, right, the browser will build what's called the DOM. So we have that huge tree structure. Then we can apply the visitor pattern to build various different things. Does that make sense? Everyone seems tired and worn out. We should everyone get up and do jumping jacks or some calisthenics, right? Just to get the blood flowing, right? Yeah. Any other questions?
Oh,
Okay, what I want to do then is I want to go on and look at undo. Right, so we've got two patterns that deal with undo. We've covered one, we're going to cover a second one. But we're all familiar with undo, right? I mean, most text editors allow you to undo, a lot of IDEs allow you to undo, right? So the question is, how can we implement undo, right? And let me give you two different use cases, but different scenarios. One is we perform an operation that has an obvious and simple inverse, right? So if I've got a counter that keeps track of a count, if I have an increase method and a decrease method, then I can use one to undo the operation of the other, right? That's the easy case, right? We're going a simple inverse. If we call increase 3 times, and we want to do that, we just call decrease 3 times, right? That's pretty simple, straightforward. In a more interesting case, if we're doing text editing, if I replace a word in a particular location, right, in the text, there's no direct inverse of that. I just can't do a global replace of replace could now with should, because there could be multiple instances of that word in a document. Or if I take 3 sentences and delete 2 of them, replace it with a third sentence, right? To undo that, we need information. We need to know, in this case, we need to know the location of the word we replaced and the word we replaced it with, right? If we are replacing, lines of text with other lines of text, we need to know what did we pull out, where did we pull them out, and what did we put in, right? So we need to, if we're going to store information, we need to store a lot more information here to be able to undo that operation, right? So the two examples are slightly different, and one is just ways of reversing a change, we call it a different function. Otherwise, we need far more detailed information about what actually happened, so we can undo it. Right? And of course, once we have undo, we need to redo, right? You've all done that, right? You deleted something in text, and oh, wait a minute, I read that, and you redo it. And again, usually you're going to do undo repeatedly, which means then you can have to do redo repeatedly. So one pattern helps here. We talked some time ago about the command pattern. And so the command processor pattern is fairly straightforward. You want a single object that will contain all the commands that were executed. And so if we're using commands that do operations, and before we execute those commands, we've given them to the command processor that can execute them. And once we've got a central place that contains all the commands that were executed, we can keep them in a stack. And then to undo, right, we take the command off the top of the stack and then have to figure out how to undo that particular operation. Right, so basic command processor is an object that contains a command stack, and you make it a singleton, so you can always access it. And whenever you got a command, you can then pass the command and tell the command processor and say, do it. And then, of course, each command then has to be able to implement an undo. So yeah, some client, so the user says create, bold, and so now we're going to make a bold command. So we may need to get this selection from the document, and the bold command, how to make that bold. Right, we create it, we give it to command processor says do it. And so you might do, every time you make a command, you do something, goes to command processor, it says do it. And then when we're done, it's like we can undo by command processor, take the thing off the top of the stack, tell the command to undo the operation. And of course, in this particular case, we have a make bold command. The command is going to have to keep track of what part of the text it made bold. So when we call undo, it can then change the font in that exact location again. Does that make sense? So they claim another number of benefits. If we keep all the commands in one place, they give us various features. We can be stored for later replay. We can log them. We can roll them back so we can get transactions. And once we have them in one place, we can sort of provide like a macro language, because now we can just, we have a bunch of commands, we send the command processor, that becomes a macro, group them together, and then we can execute that group as a whole. Testability. Now we can write tests to create a bunch of commands, give it the command processor, tell them to execute it, and then we then query the state of the application after we've executed those commands. And concurrency, if we're have a central place that actually does execute the commands, and we can have that command processor execute in different threads if we need to or want to. Well, loss of efficiency. We've just added another level of direction, right? We went from, you do this to, okay, I'm going to bundle it up, and then you tell him to do it. Now what we're going to do is we're going to tell bundle it up and give it to this person, and that person, you tell this person to tell this person to do it, right? So instead of us, the client telling, calling method directly here, we create a command, give it to the command processor, and then tell the command processor to execute, and then tells the command to execute, and then actually does the operation. And, if we're going to do this, say in Microsoft Word, every possible way in which we could modify the document we're working on has to be done in a command, right? Send the command processor. And how many ways are there to modify a Word document? Right, we can change rulers, we can type in text, we can, various menus we can use to modify the text in some way. But now think about it. If you were going to implement a word processing application, how would you implement undo? Right, but you have to keep track of what was done, where it was done, and have a central location for all that information. The second pattern, which is related to undo, is called memento pattern. And the pattern is pretty straightforward. You just take the internal state of the object that you're going to change, and you copy it before you make the change, and then you can change the object. And then if you want to do undo, you can take that old copy of the state and replace it back into the object. Make sense? Now, it does lead to certain problems. So, first of all, they're worried about information hiding. If I'm going to make a copy of the internal state of the object, they're like, we don't want everyone else to see it. We just want to save it over here. So they worry about violating encapsulation, information hiding. The second problem is we need a place to store that state, and we need to know what object goes back into, right? And so the pattern talks about, okay, we want the object we're going to make a copy of to have a, basically a, create memento method, return an object which contains a state, and then a way of passing that state back and saying, telling the object to replace all this information with this new set. So one, possible way to implement this in Java is just, create a hash table internally, and then, basically a get and set state. Operation. And then, we've got some fake example where I have a bunch of fields, a create memento method, then just creates a memento, passes it, creates a memento, passes it, returns it. And the restore state method just pass a memento, and you grab all the data out and replace your current values of those fields with the old ones. sort of hard to believe people got famous for saying all you do is to copy the state, but there we go, right? Um, like I said, one issue is once I pull the state out, right, I have to keep track of where it goes back into. And so one obvious way to try and solve that is just add a stack to every object. And then when you call create memento, it just pushes that on the internal stack. And then restore memento just pops thing off the stack and right. It does solve the problem of how to keep track of which memento goes with which object, but it causes several other problems. If we're going to use this for undo, we have, and if each object has their own internal stack, we have no idea which operation undo next, right? I've got 10 objects and they all have a history of their own local history. Which was the last object which was changed? Don't know, right? So we're not going to be able to use this for undo to keep the application in sync. The second problem is that means now that whenever we use this object, even if we are not interested in undo, we're still accumulating all copies of the object every time we make a change, right? Because every time I call a method to change one of these fields, or I call create memento, I'm storing it locally, and that could get very expensive. Some consequences of patterns, it can be expensive because every time you make a change, you make a copy. How many copies do you make, right? Over time, space, you talk about narrow and wide interfaces basically mean we want the memento not to give access to the data to the outside world, so it's a narrow interface, but internally to the creator should be able to access all the data inside the memento. So one way of doing that is make it a private class inside the originator, which means it's the only one that can access fields on it. And C++, we can make all the operations private and then make the originator a friend. But that doesn't mean much to people in the class because that many C++ people. In Java, we can sort of do this by cloning right, by just cloning the object. This causes the two things you have to worry about. One is if I'm just cloning the object, now we're passing back a memento object, so it only knows that's clonable. So we don't have to worry too much about information hiding. But the real issue is when I'm copying the state of an object, how do I copy it? And say I've got a door object, and the door object contains a reference to two room objects, and each room object has a reference to a chair. If I do a shallow copy, now I've got two door objects, all right? But they all point to the same room. So if I use one of those door objects to access the room, to access the chair, and then break the chair, or paint the chair, both copies of the door object eventually have the same chair object. And if we're doing this for a memento, we don't want that to happen, right? We want to make a copy in the memento, and that copy never changes, so I can go back to the original state. So if we're making a copy of the state of an object, we have to then make a deep copy, or copy all the way down, right? Is the issue clear here?
Couldn't this be done with object serialization? You still have an issue with shallow and deep copies, but it seems like it might be more efficient.
Well, so the question is, can we just serialize the object and reserialize them? That is an expensive process too, right? You still have to go down that object graph, and for each object you have to then convert it to some format that can be usually some textual format or some binary format we can use to recreate the object. So I don't think you'd find that any less expensive. No. Yeah, it's not clear because that's why you're copying objects, you have to create the memory. Yeah, and C++ always gives interesting issues. If you're using clone in Java, you have to worry about what level of cloning you're doing. In one place, this is used as for experimenting. What happens if I do this, right? So make a bunch of changes, see how it goes. Oh, no, not so great. Roll back, right? Basically one one example of doing that is source control, right? You check your code in, right? And then you're gonna I'll check it out in a different branch, right? Make some changes to see if that works out. Oh no, I don't like that idea. So I go back to the original. So I'll check out the original back again, right? Same idea in terms of when we check source code in, we're going to make a copy of the current state of the source code. Of course, we're doing it as text and we're going to do it efficiently. It's the same idea as Memento. We'll make a copy of the current state. Now, recently, functional programming has become popular, and one of the ideas there is you make all your data structures immutable. And if the data is immutable, then we don't need a immutable pattern because every time you want to change a piece of data, you actually make a copy anyway. So we've run out of time. And we have to think of a way of how can I deliver espresso to everyone's house before class starts, right? Get everyone sort of jazzed up. So I'll see everyone on Tuesday, and we should know who's going to be president so we can stop staring at the news feeds, see what can happen. Okay, we're done for today.
Thank you.
Thank you.
Thank you. Thank you.